So we're going to look at Newton's second law of motion in two different videos. So this is going to be our part one. Part two is going to involve pulley and tension. So if you're looking for that, you want to skip over to part two. So in this video, we will look at what Newton's second law of motion is, and we'll start performing some calculations with Newton's second law. So what is Newton's second law of motion? Basically, it's telling us that F is equal to ma. So force is equal to mass times acceleration. So the more force we have on something, the faster something will move. So that's really all we're looking at. And so generally here we're not looking for a net force that's equal to zero. We want our objects in motion. So most of the time here we're going to be dealing with unbalanced forces. So we're going to be dealing with things moving. So if we look at this one, we have a net force of 45 newtons forward. So let's write down what we know. So we have 45 newtons forward. And we have a mass of 0.32 kilograms. So we use kilograms as our standard for mass in physics. In chemistry, we use grams, but here in physics, we will use kilograms. And we're being asked for the acceleration. So the acceleration and the net force are always going to be in the same direction. So our ball is going to be accelerating forward. So let's write down our equation. So our equation is F net equals mass times acceleration. And then if we want to rearrange that for to solve for A, we would divide both sides by m. So I'm just going to rewrite that in the other direction. So acceleration is equal to F net divided by mass. So then we can go ahead and put our information in. So we have 45 newtons and we have a mass of 0.32 kilograms. So remember that a newton is equal to a kilogram times meters per second squared, okay? So if we were to replace that, our kilograms are going to cancel out, and that's how we get our units of meters per second squared. I know some of you want to know where that comes from, and some of you are okay with just remembering that acceleration is meters per second squared. But that's how we would actually do it. So if we did kilograms dot meters per second divided by kilograms, the kilograms cancel, and that's how we get our units of meters per second squared. So when we do that, we get 140 meters per second squared, and it's forward. All right, we only want 2 sig figs, so we're going to round so that it's 140. You might also see it in your textbook as 1.4 times 10 to the power of 2. It's the same answer. So let's look at something a little bit harder. So here we have a 70 kilogram runner. And we now have a V1 of 2.5 meters per second west. We have a V2 of 15 meters per second west. And we're told that that takes 45 seconds. And it wants us to calculate the net force. In order to calculate net force, we need to put it into F equals ma. So in order to calculate net force, we need our acceleration. So that's going to be our first step, is to find our acceleration. So we're going back to kinematics here, and we're going to go and we're going to look at our formula sheet and figure out which one we can use. So we can use V2 equals V1 plus AT. And if we rearrange that, we would do V2 minus V1 equals AT, and then we would divide by T. And you'll see that that actually works out to our standard acceleration equals the change in velocity over time. Just make sure that if you're given displacement for whatever reason that you are using one of those 5 key equations. So this is actually equation 2 from the 5 key equations. So I'd rather you use that than revert back to using one of the simple formulas, just in case you should be using one of the 5 equations. So let's go ahead. I'm just going to flip it around, but I'm going to put my information in at the same time. So we're going to do 15 minus 2.5 all over 45 seconds. So this is meters per second. So our acceleration is 0.278 meters per second squared. So we should actually try and keep extra sig figs there, because that way your rounding issues won't be so big. So now I'm going to just switch my color here so that it's easier for you to see. So then step 2 is going to be to find F net. So to find F net, you're doing your mass times acceleration. So we don't need to rearrange that because we're trying to find our F net. We have our mass of 70 kilograms, and then we just calculated our acceleration. Sorry that it's kind of getting a little messy there. And we want to round so that we have 2 sig figs. So when you do that, you get 19 newtons. And then we always want a direction. And so our velocity is in the west direction, which means our acceleration, we should have written down west. So example 3. So now we've got a 11,000 kilogram jet taxiing on the ground. It fires its engines, resulting in a force of 27,000 newtons east, and it has a force of friction of 4,300 newtons west. So let's start by drawing our free body diagram. So there's our applied force. Here's our force of friction. We also, of course, have a normal force and a force of gravity that are balanced out, okay? So we should include those anyway. Oftentimes, too, we will include the mass of our object just kind of off to the side. That way, all of our information is there. So that's our part A. So part B is asking us to calculate our net force. So our net force is going to be our applied force minus our force of friction. So F net is equal to 27,000 newtons minus 4,300 newtons. So our F net is equal to 22,700 newtons. It's positive, so that means it's in the east direction. So that's part B. Part C is asking us to calculate the acceleration. So when we want to calculate acceleration, we use F net equals ma. So we already rearranged this equation, so I'm just going to write it down already rearranged. And then we will put our information in. And we want 2 significant digits. So we're going to round that to 2.1 meters per second squared, and that is in the easterly direction. So that is the acceleration of our jet. So in this video, again, we just reviewed kind of the basics for Newton's second law of motion, really just using that F net equals ma. So solving for all of those different things.